Hi, Ms. Lisinski here, and today we're going to do an experiment about soil and carbon dioxide and connect that to climate change and feedback loops involved in climate change. So we've got both positive and negative feedback loops that impact climate change, and a positive feedback loop is going to, you might remember, that's going to amplify that effect. So that's something that's going to make global warming worse. Negative feedback loop is going to stabilize something. So in this case, with global warming, it's going to reduce the effects of climate change. So just to show you one classic example of a feedback loop involved in climate change, we've got albedo, which is how reflective a surface is. So ice has a high albedo, it reflects a lot of light. As it melts, it turns into darker ocean water, which is going to absorb more heat, reflect less light. So you can think about how that is going to impact climate change if we have ice melting. And the next thing that's going to happen is that ice is going to disappear, and we're going to have more heat absorbed by darker ocean water. In other words, the albedo is lower now, more heat is absorbed. That's then going to increase temperatures on Earth, which of course will melt more ice, and this cycle continues. So this is a positive feedback loop that amplifies climate change, makes things worse. So with this demonstration, I want you to keep feedback loops in the back of your mind and try and figure out what is going on here. So what I have is, first of all, I have some carbon dioxide sensors. These can sense the levels of carbon dioxide gas in the air. I'll show you. I've got both channels on here. Let me actually make this big. We've got both channels on. Looking at these, oh wow, they're pretty similar now. Earlier today they were reading quite differently from each other. So now it looks like they are pretty similar. That's good. I'm also noticing the levels, the level of carbon dioxide in parts per million in our atmosphere right now is about 412 parts per million. So this is a little high, perhaps because it's next to my head where I'm breathing. We breathe out like 40 to 60,000 parts per million carbon dioxide. So that is probably impacting things. Put it back over here. So what I'm going to do is I'm going to put these two carbon dioxide sensors into 2 jars of soil. They're both taken from the same place right outside school. This one has been in my room at room temperature all day, and I'm going to go grab another one from the freezer. Okay, so I've got my soil that was frozen, soil that is room temperature. I feel like I should try to air them out a little bit. Okay, so I'm going to put channel 1, first one on top. Let's put that in the frozen soil. Channel 2 is going in our room temperature soil. Looks like this. I can already see a significant change here. Looking at these numbers. Channel 1 here is our frozen soil. Channel 2 is the room temperature soil. We'll just watch this for a couple minutes. You can tell they are very different. Both are increasing. Seems kind of out of focus here. Both are increasing, but we've got the room temperature soil increasing a lot more rapidly here. So think about why this might be. First of all, what in soil would be producing carbon dioxide in the first place? Why would this happen more when we have warmer soil? Okay, so for why soil makes carbon dioxide, there's something alive in there. We've got things like bacteria and other microorganisms that are just like we do, breathing. They're doing cellular respiration, which makes carbon dioxide. The reason they are letting off more carbon dioxide when it's warmer is because they're going to have a higher metabolism. In other words, their bodies are doing more chemical reactions as things get warmer. Molecules move faster, chemical reactions happen faster. That bacteria is going to be more active and producing more carbon dioxide. It's continuing also to go up here. We're now at 634 for our room temperature soil. No, sorry, for our frozen soil. And 2,920 for our room temperature soil. So the reason this has to do with climate change and with feedback loops has to do with permafrost. So permafrost is just a layer of soil that is permanently frozen year-round. You can imagine with climate change, some things that used to be permafrost are now starting to melt. Within that permafrost, we have all kinds of bacteria and microorganisms that are now becoming more active, doing more cellular respiration, and creating more carbon dioxide. Carbon dioxide is not actually the only greenhouse gas impacted in this situation. We also have methane that can be released. That can come from just pockets of methane that had been frozen under there, and as things thaw, they can be released. It can also come from decomposition. Methane can also be produced that way. And methane is a much stronger greenhouse gas than carbon dioxide, about 25 times stronger. So this is important. So let's see if we can put a feedback loop together for carbon dioxide and what's going on here. So we've got more greenhouse gases in the atmosphere, which are warming the Earth. That in turn makes soil bacteria more active, does more cellular respiration, making more carbon dioxide, which is more greenhouse gases in the atmosphere. So this is another positive feedback loop that is making climate change worse. There are some negative feedback loops as well, but these two we've talked about today are pretty significant.